Hey there, I'm doing an introductory segment on carboxylic acids and their derivatives, and I'm working with some new technology, so I'm hoping things work out for me. If not, please be patient as I fumble through it. I don't have a lot of time for edits. So one of the things about the carboxylic acid group is that it contains a carbonyl group, and this right here is that carbonyl group. We saw it before with aldehydes and ketones, and in a carboxylic acid we have a hydrocarbon chain, and at the end of that hydrocarbon chain is the carbonyl group attached to a hydroxide group, or an OH. We have the carbonyl group and an OH bonded to that. Some derivatives of carboxylic acids include, I have to turn the pen on each and every time, and that's kind of annoying. Esters are very similar, or esters are derivatives of carboxylic acids, and we're going to learn that when you combine a carboxylic acid with an alcohol, we produce an ester. An ester can be recognized by this right here. In the middle of a hydrocarbon chain, or hydrocarbon chain on either side, we have a carbonyl group, and in here an oxygen is part of that chain. An amide is very similar in that we have a carbonyl group, and instead of that being an oxygen right there, it's a nitrogen. So esters are always going to be found with hydrocarbon chains on either side of them. However, amides can be found with only one carbon, or you can find this amide group attached to longer hydrocarbon chains. So there are several different variations depending on the type of amide it is. There will be a later separate video specifically on amides. So the carboxylic groups can be, the carboxylic groups can be represented a variety of ways. So in a structural diagram, you'll see how the atoms are put together here with the carbonyl group at the end of the hydrocarbon chain and an OH. Another option is to see a COOH, or sometimes you see a CO2H. So those are different ways of representing that group. I have to say the most common are this one right here and the COOH. So carboxylic acids can be either aliphatic or aromatic. Now what that means is the aliphatic carboxylic acids are just regular straight and branched chains with the carbonyl group stuck on the end. An aromatic carboxylic acid is where the carboxylic group is attached to a benzene. So on the next slide you'll see carboxylic acids that are aromatic. This is the most basic aromatic carboxylic acid compound in which the carboxylate group is attached to a benzene. So naming carboxylic acids are very similar to what we're familiar with. You have to find the longest continuous carbon chain that contains that carboxylate group. So again, that's always going to be at the end. One thing you do need to make sure you're careful of is making sure you pay attention to any branches that may cause the longest continuous chain to bend and twist. So that is a common way to make mistakes when naming any organic compound. The number one carbon is always the carbon attached to the carbonyl, so I like to call it the carboxyl carbon, and that's always number one. The name of this is 3-methylpentanoic acid. So we have 5 carbons. We have that pentane prefix, the pent prefix that we're accustomed to. And instead of saying pentane, we say pentanoic acid. So one carbon carboxylic acid is called methanoic acid. A 2-carbon carboxylic acid is called ethanoic acid. And 3-carbon is called propanoic acid. So something that's sort of interesting about methanoic acid is a common name for it is called formic acid, and it is found in ants' saliva, and it is what you feel when you get that ant bite and there's that sting. It's the formic acid in the ant saliva that's causing that burn. Ethanoic acid, its common name is acetic acid, which is the main ingredient in our vinegars. And propanoic acid is also called propionic acid, and it gets produced in our sweat glands, and it can be often a byproduct of bacteria in our sweat glands that are producing it as a byproduct. So this page doesn't include the propionic or propanoic acid, but it does talk about the formic acid and the acetic acid. Another one is called butyric acid. Its IUPAC name would be butanoic acid, and it has a very rancid, terrible odor. It smells like vomit, I think, or butter that's gone bad. So one of the older naming schemes of carboxylic acids goes back to, rather than numbering the carbons like we're accustomed to, it refers to the carbons that are next to the carbonyl carbon in ways that represent the Greek alphabet. So we would call this number 2 carbon the alpha carbon. This would be called the beta carbon. This would be called the gamma carbon. And I do not remember what this one is called. It might say it. It might say it eventually. Now, sometimes in a really long hydrocarbon chain, they will say that the very end carbon is the omega carbon, and omega is the end of the Greek alphabet. So when we start talking about fatty acids, that's going to come back, and we'll talk about that. So if we have a group, a branch attached to any of these carbons, you can typically name it 2 ways. You can name it with the number 2, or you could call it alpha. So I want to remind you that this is the carbonyl carbon, and this naming of the groups that are attached are based on the Greek names. So this is the alpha carbon, the beta, the gamma, and I'm sorry, I don't remember what that is. So if we look at this system, this image right here, you'll see that our longest hydrocarbon chain is right here. We have 1, 2, 3, 4 carbons, and we have this COOH, which identifies it as a carboxylic acid. And then we have a hydroxy group attached to the number 2 carbon. So this is the number 1 carbon, this is the number 2, 3, 4. So 2 ways this can be named is to say alpha hydroxy butyric acid, which is a common name, or 2-hydroxy butanoic acid. You may also see the 2 replaced with the alpha and have the alpha incorporated into the IUPAC naming scheme. So that is a common occurrence. So here's another example. We have 1, 2, 3 carbon carboxylic acid. On the second carbon we have an amino group, and 2 options are, we could call it alpha amino propionic acid, which is the common name, or 2 amino propanoic acid. And And here is another one. I'm going to show the pen here so that I can draw this out. So here I have a carbon attached to another carbon. So I have 1, 2, 3 carbons. Attached to this first carbon, I have 2 hydrogens. I shouldn't call that the first carbon. It's the first carbon that I drew on the paper, but it's not the number 1 carbon. I have a chlorine group, so this Cl says it's being attached to that. And I have 2 hydrogens attached to that carbon. And then this is my carboxylate carbon, which has the carbonyl group and the OH. So this is my number 1 carbon, this is my number 2 carbon, and my number 3. So the number 2 carbon is also known as the alpha carbon, and the number 3 carbon is known as the beta carbon. So 2 ways we can name this are beta chloropropanoic acid or 3-chloropropanoic acid. So number 1 carbon, number 2 carbon, number 3 carbon. Here is a list of some common names. Now what I find interesting about this is they have methanoic, which is 1 carbon, and ethanoic, which is 2 carbons, and butanoic, which is 4 carbons. But the last couple examples were propanoic acid, which they're not including on here. But here are some common places that these carboxylic acids occur. The ant saliva, vinegar, butterfat, 3 types of carboxylic acids found in goat fats, palm oil, and beef fats. So one of the things we're going to find out or discover, especially when we start talking about lipids, is that the fatty acids are carboxylic acids. So that's why it's important for us to learn about them now. Sometimes we can have carboxylic acids with 2 or even 3 ends. So these are dicarboxylic acids. I shouldn't have said 3 ends. I'll just kind of back up a little bit. Right now I'm talking about dicarboxylic acids. Oxalic acid is known as ethanedioic acid, and its structure looks like this. So we have a carboxylate group at this carbon, and then another one at this carbon. And notice that I drew OH over here, but I'm drawing HO here. Again, that's a reminder that this bond is to the oxygen, which is then bonded to the hydrogen. So oxalic acid is a component found in rhubarb, actually. It's a toxic component, and I believe it can also be found when the sun hits a potato that's growing under the ground. And when the sun hits it, it gets that green spot on the skin of the potato. You're not supposed to eat that because it's just not very good for you. Malonic acid is a propane dioic acid. So if I add, oops, I made a mistake. I'm not going to erase. I'm just going to move over and draw it right here. So again, a carboxylic acid group has to be on an end carbon. It could be this end carbon, or it could be this. So this is what propane dioic acid would look like, which is also known as malonic acid. Succinic acid is butane dioic acid, and I get so impatient with this pen. Butane dioic acid, so we have 4 carbons, and I'm not going to draw all the hydrogens on there because I think that you get the point. Again, each of those carboxylate groups on each end. And then pentane dioic acid is 5 with a carboxyl group here and a carboxyl group there. Sorry, I just realized I look like a kindergarten's drawing this.